Alright, here we go. This is going to be our surface area and volume review day video. Sorry I wasn't able to be in today, but hopefully this will give you a good overview of how the sphere homework worked, as well as what kind of stuff to expect on the test tomorrow. So, here are your solutions for the homework from 10-7 that you would have done last night. Take a look at them. You can pause this video. I'm going to go ahead and move on to a few problems that I think will be commonly missed and that I've gotten emails about. If you have other specific problems, try to find somebody in the class who can explain it to you, and if you can't, send me an email. I will be checking emails today. Alright, here's problem 23. This one seems to give people trouble, but all you really have to do here is calculate two volumes. First, the volume of the frozen yogurt, and that's a sphere, so you got a radius of 4 here. Your volume formula is going to be 4/3 pi r cubed. So you plug that all in, you calculate it out, you see what it is. You compare it to the volume of the cone. When you look at that cone, also a radius of 4, and we've got a height of 12. That volume formula is going to be 1/3 pi r squared h. Anyway, you compare the two volumes. The frozen yogurt volume comes out a little bit bigger, so it is an overflow. Here's number 42. This one's a little tricky to interpret at first, but what they've got going here is a cylinder with half of a sphere kind of carved out of the top of it. And one thing that's a little tricky here is the height of the cylinder is 2.5, but the radius of the sphere is only 2, so it's actually not hollowing it out all the way to the bottom. There is a little bit of thickness down here towards the bottom. Here are the calculations that you would use to figure out volume and surface area. So, for volume, you want to look at what you've got total for the cylinder, and that's going to be pi r squared times h. So you see that 4 pi coming from pi r squared with the 2 radius, multiplied times the 2.5 height. Then we're going to subtract out half. That's what half of a sphere, so that's what this half is about. And then 4/3 times pi r cubed with a radius of 2, r cubed becomes 8. So you see that, you work it out, and you saw the solution on the last page. I believe, let's see, this would be 10 pi. This would be 2/3 of 8 pi. I'll just flip back and take a look at the number. 42, it comes out to 22 pi for the surface, or 14 pi over 3 for the volume. So you'd have to get a common denominator to do that subtraction. Surface area, you're going to look at it in pieces for the surface area. On the bottom of the thing is still sitting a regular circle with a radius of 2, so pi r squared, that's 4 pi. Along the sides of the cylinder, the lateral area of a cylinder is going to be 2 pi r, that's the circumference times the height, so we have 4 pi times 2.5. And then we also need to, on the top of the thing, it's got this hollowed out half sphere. We're going to figure out what the surface area for that is. So normal surface area for a sphere is 4 pi r squared. So I'm just going to use 2 pi r squared to get what half a sphere would be. When I add all of these up, it should come to 22 pi. Here's problem 53. A couple of people had questions on this one. The key piece of information here, it has a circumference of 41.5 feet. From circumference, we can use 2 pi r and get the radius, and once we have radius, we can calculate the volume of the ball of string. Here is the work that will lead you to h as your best answer. Starting with 2 pi r equals circumference, so I divide the 2 pi on both sides, and I get 6.6 for the radius. Then I just plug that into 4/3 pi r cubed. 6.6 cubed comes to about 288. Multiply that times 4/3 times pi, I get 1207, so the best approximation would be 1200. Here's another problem. This is not from the homework, but this is something that it's kind of similar to what you might see on my test, so I wanted to just give you a chance to see it. If you got volume of a cylinder at 500 cubic meters, what's the volume of a cone with the same height and radius? Well, this is sort of an interesting problem because we're not told the height or the radius, we're only told the total volume. So at first glance, you sort of start thinking, I don't know, there's all these different combinations that might lead to a volume of 500 cubic meters. So how do I figure this problem out? And what you really have to do here, if you like, you can pause and think about it for a minute and try to figure it out yourself. I'm going to go ahead and explain. So pause now if you're going to pause. Okay, so here's your explanation. You need to compare the two formulas. So volume of a cylinder with volume of a cone. And if you write them out, you will notice they look extremely similar. The only difference is that when you look at the cylinder, you have pi r squared h. For the cone, you're 1/3 pi r squared h. So basically, you know the cylinder's going to have 3 times as much volume as the cone. Or think of it the other way, the cone is going to have 1/3 the volume of the cylinder. You just need to divide 500 by 3 to get your best answer here. I believe that's 167, but I'll double check with my calculator. 500 divided by 3. Yes, 166.666. Since they're asking you to round to the 10th, it would be 166.7. All right, here's one more problem that is going to ask you to think a little bit, and it's kind of an application sort of problem. This is a historical one. Archimedes asked that such a figure as this be put on his gravestone along with the ratio of their volumes, which he considered to be something really, really significant. What is that ratio? So let's see if we can't figure out the two numbers. We've got a cylinder with a sphere fitting snugly inside it. So obviously they have the same radius. But the other key thing you've got to see is if you want to know the height of the cylinder, it's going to be the diameter of the sphere. We're assuming that it fits snugly on left, right, and top, bottom here. So if we think about it and we look at those formulas, we can figure it out. So volume of a cylinder is pi r squared times height. So if we think about pi r squared times height, and then we compare it to... Alright, sorry about that interruption. I wrote down some stuff and hopefully I can make this a little more clear now. So you've got pi r squared h for the volume of the cylinder, and you've got 4/3 pi r cubed for the volume of the sphere. You know that the radiuses are the same. The other thing you know is that the height of the cylinder is actually like 2r, so I'm just going to substitute here. I'm going to drag it over so it doesn't spill into the next line. So now all of a sudden you can see there's actually r cubes on both sides, because r squared times r would make an r cubed. There's pi's on both sides, and we can actually really quickly just cancel our array down to 2 to 4/3. So 2/1 comparing to 4/3. So what we've got, because the one we've got here is a little bit hard to compare because you've got a whole number on the left and you've got a fraction on the right. It might be easier to think of it as 6/3 comparing to 4/3, which is like 6 comparing to 4. So if you think of it that way, 6 is to 4 as 3 is to 2. So what they're actually looking for here is a 3-to-2 ratio. Alright, that brings us to the end of our practice problems here, but you can go on and do some more at the website that I linked. It's that same one with all the practice tests on it. It's got a lot of good applicable problems that are similar to what you might see on the test. So good luck, and don't hesitate to email me if you have any questions or concerns. Alright, have a great day. Good day.